Ball of mass M falls vertically from a height of 4h onto a marshy ground with resistance of magnitude 8 mg newtons. Find in terms of h the depth at which it penetrates the marsh. Now the first thing I'm going to do is just going to find out how fast it hits it. Okay, so we're going to have the particles up here, and we're going to hit the marsh. Now the deal is the reason why it's fallen is because of gravity, right? And weight is mass times gravity. And because it's mass m, it's just going to be m multiplied by g, which is mg. Okay? If I was 20 kilograms, it'd be 20g. If it was 100 kilograms, it'd be 100g. The heavier you are, the more force of gravity that acts on you. Okay? Now, next thing. So, what happens next is we do u vast, okay? So we go u is 0, v we don't know is what we're after. We're after a, which is gravity, which I'll keep as g, just because I think they'll cancel eventually anyway. S we know is h, isn't it? 4h, thank you, because it drops a distance of 4h. Good to know. And then you're gonna think I'm gonna use phi squared equals u squared plus 2as. And I'll use phi squared equals 0 squared plus 2 times gravity times 4h. And phi squared equals 8gh. And then square root it, and you get root agh. Is that okay? We all good? Okay. Now, next thing. What I'm thinking of is we have 8gh here. Okay, and then I'm going, okay, we have 8gh. So it hits the marsh. And it's going to slow down, and it's eventually going to stop, isn't it? So eventually v will be 0, but as it hits the marsh, its new velocity is 8gh. Is that okay? Now, it's a bit of a wrestling match, okay? Find in terms of h the depth to which it will penetrate the marsh. So basically means the final velocity is 0. Okay, so here's what we're thinking. It's 7 mg up, or is it 8 mg? It's 8 mg up and 1 mg down. So your weight minus the resistance. So who's winning that battle? 8 mg is winning that. So there's going to be a net deceleration of 7 mg net deceleration, okay? Now, if we do u vast again, u this time is root agh, phi is 0. We haven't got a yet. We haven't got s is the goal of the question, isn't it? We haven't got t. However, what I'm thinking about doing is the following. I'm going to say F equals ma. The net force is 7 mg going upwards, and this has to equal ma, and the acceleration is going upwards. And I think therefore the a value has to be 7g. Is it slowing you or speeding you up? So it's going to be minus 7g. Okay, and then we're going to put that in the calculator, and we're going to do u vast. So I'm going to do phi squared equals u squared plus 2as again. I'm going to get 0 squared equals just going to be 8gh, isn't it? And then minus 14g, because 2 times minus 7g. I'll just call this x because my s's look like 5s. Alright, move all over one side. 14g equals 8gh. Cancel the g's and divide 14 by 8. What is 14 divided by 8? I think it's 1.75, but you guys can tell me. To use, made 2 mistakes there, oddly enough. That's meant to be an x. Yeah, I see the issue. Yeah, I messed that up. So it's 14gx, isn't it? And 8g, h. The g's cancel. and the x will equal 8 over 14 h, which is 4 over 7. And that's my answer for part 1 in terms of h. Would a ball of mass 4m drop from a height h penetrate the same distance? Justify your answer. Okay. Now here's where it wouldn't. I'll explain why. The first reason is it still hits at the same speed. Do you remember when you drop a feather on a bowling ball in a vacuum? They both drop at the same time, yeah? So that means that this mass here, that mass there is completely independent of the weight. Agreed? That's before it hits the marsh. But let's be honest, a bowling ball hitting a marsh versus a feather hitting a marsh, we all feel there's a difference there, don't we? That the bowling ball should go deeper. If they're point masses as well, they're both considered to be the same size. So let's investigate what would have happened differently. Instead of 7 mg, so it would have been 8 mg going upwards, wouldn't it? Would you all agree it'd be 8 mg going upwards? And it wouldn't be mg going downwards. Why not? It'd be 4 mg. And this would result in a net force of 4 mg upwards. And then we would have redone this last step. Do you remember it was 7 mg, wasn't it? So I'm just going to rub all this out for a minute. And I would have said, well, look, so then I would have said, I would have said MA. So force equals MA, but MA is actually 4MA because it's mass times acceleration. And that equals 4 mg. And oddly enough, your acceleration would have equaled gravity. But it's gravity in the opposite direction. And I think last time it was a bit bigger than that, wasn't it? It was 7g, was it? So it has 7 times less deceleration, which hence means it will sink deeper.